Hey, it's Mr. Barrett. Just doing a really quick video for you on how to solve two-step equations. It's really nothing more than using opposite operations. For example, if you know that the opposite of adding 5 is subtracting 5, or the opposite of dividing by 10 is multiplying by 10, then you can come up with your answer really easily, because all you have to do is just look at isolating the variable term and then isolating the variable, and then just checking your answer. So, what if I gave you something like this? 2x minus 5 equals 15. Well, first thing you have to do is isolate your variable term. Your variable term is your variable with whatever's happening to it. In this case, we're multiplying by 2. So we want to get this variable term, 2 times x, by itself. So we split the left and the right side of the equation. You should always write this down while you're learning this skill to make sure that you realize there are two separate sides. And whatever you do to the left, you must do to the right. So if we want to get 2 times x by itself, what's the opposite of subtracting 5? Adding 5. So whatever we do to the left, we're going to do to the right. So these two things cancel out in terms of negative 5 and positive 5 equaling 0 when they're combined. So you have 2 times x, you've isolated the variable term. Remember, isolate means to get by itself. And you have 15 plus 5 is 20. Now we isolated the variable term. Now we want to isolate this, just the variable. So what's the opposite of multiplying times 2? Yeah, dividing by 2. So all you have to do is divide by 2 to isolate x. 2 divided by 2 is 1. 1 times x is still just x, because 1 times anything is that thing. So 1 times x is x. And if we divide by 2 on the left, we're going to divide by 2 on the right. 20 divided by 2 is 10. So x equals 10. What do you have to do? You have to check your answer, because we all make mistakes in this world. So you start by writing your original problem. Say 2 times x minus 5 should be equal to 15. After we start with the original problem, we plug in our answer, which we say x is equal to 10. So 2 times, it's no longer x, it's 10, minus 5 should be equal to 15. 20 minus 5 should be equal to 15. Yes, 15 is equal to 15. So it's a very straightforward process, nothing tricky about it. Okay, again, two-step equation. We're going to isolate our variable term, in this case, x divided by 2. So let's go ahead and let's separate the left and the right of this equation. We have to do the opposite of adding 30, which is subtracting 30. It's an equation, so whatever we do to the left, we're going to do to the right. Whatever we do to one side, we have to do the exact same thing to the other. We combine positive 30 and negative 30, we get 0. So x divided by 2 plus 0, we don't have to write down plus 0, is equal to 50 minus 30. So x divided by 2 is 20. Well, let's say this. Let's say you're confused because of the way it's written. I'm going to just rewrite this for you. Mathematically, these are the same statement, and I didn't change not a thing. So I'm going to go to step 2 now. I'm going to isolate the variable. This is my variable, so what's the opposite of dividing by 2? Multiplying by 2. Whatever I do to one side, I'm going to do the other. So x equals 20 times 2 is 40. So really easy. But we have to check because none of us are perfect. So let's go ahead and let's look. Our check, we always start off with the original problem, which was x divided by 2 plus 30 must equal 50. We're going to substitute in 40, what we found for the value of x, and we're going to check if this equals 50. Well, we get what? 20 plus 30 is equal to 50. And when we do that math, yes, 50 is equal to 50. So it checks. We know we have the right answer because the left side and the right side are in agreement. They equal each other. Let's give this last one a try. It's got a little bit more meat to it, so see how it works for you. All right. 1/3 of y, or 1/3 times y plus 2, is equal to 3 1/2. Or 3 1/2 is equal to 1/3 times y plus 2. Remember, everything works exactly the same. Fractions don't change the process. They only change the arithmetic. We got to get the variable term by itself. So let's isolate 1/3 times y. Well, if we got to get this by itself using opposite operations, what's the opposite of adding 2? Subtracting 2. Whatever you do to the right, you must do to the left. So let's take away 2 here. 3 1/2 minus 2 is 1 1/2. And 2 combined with negative 2 would be 0. So we have just 1/3 times y, which is our isolated variable term. Okay. What's the opposite of multiplying by 1/3? Well, it's dividing by 1/3, which mathematically is the same as multiplying by 3. So let's multiply times 3 over here. Let's multiply times 3 over here. Okay. When I do this with my students, I normally teach them that it's safer to convert to an improper fraction and then multiply. But in all honesty, you can do it. You can almost think of it as a distributive property problem. So what's 3 times 1? 3. And 3/2 would be 3/2. So we get 4 1/2 is equal to, these two things cancel out, times 3 divided by 3. They're opposite operations, so we isolated the variable. And we have just y. So our answer is 4 1/2. You say, well, how do we check that? How do we know we're right? Same process. You start with the original problem. It's just going to take a little bit more arithmetic. But we've got 3 1/2 is equal to 1/3 times y plus 2. So 3 1/2 is equal to 1/3 times 4 1/2 plus 2. Well, when we're multiplying, we're going to convert these to improper fractions so that we can do our work easily. So we've got 1/3 times 2 times 4 is 8 plus 1 is 9. So we have 9/2 plus 2 is equal to 3 1/2. Well, order of operations, what do we do first? Well, we've got multiplication first. So let's go ahead and factor out. And we've got 1 times 3 is 3. 1 times 2 is 2. So we've got 3/2 plus 2 is equal to 3 1/2. This is 1 1/2. So 1 1/2 plus 2 is 3 1/2. Remember, how many times does 2 go into 3? 1 time with a remainder of 1. So that's where we get 3 1/2. Sorry, 1 1/2. And when we add that 2 to 1 1/2, we get 3 1/2. And we have 3 1/2 over here. Left side equals the right side, so we know that we're good. All right, remember, always check your work. And if you don't know what to do, isolate those variable terms and those variables by using opposite operations. Okay? Same thing here by using opposite operations. All right, have a good one. It's Mr. Barrett.